Okay, we're going to go ahead and do problem 1.2. And the problem or question is asking for, well, I'll read it. How many electrons does each of the following elements have in its outermost electron shell? And again, for most of you, this is review from your first semester of chemistry when we were dealing with electron configuration, and that sort of stuff. But so it's review, but nonetheless, we're going to go ahead and sort of go over some stuff that most of you probably already know. Let's go ahead and start with this here, numbering and doing the blocks and what have you. So remember, basically this here. Let's do the blocks first. From here to here, from your hydrogen to your helium, we're going to make sure we're going to put helium over here. We're going to move it. It should be here, but it's going over here. We're going to stick it in the S block, which is fine. This is your S block, as you all remember. This here, let me try to do this a little bit neater. This here, it didn't work out too well, is your D block. This here, including your noble gases, your group 7, your halogen, group 8, your noble gases. This whole thing is your P block, and this is your F block, but we do not need that. Now, this is your group 1, 2. These get a little squirrely in here, your transitional metals, and we're going to get to that. This is group 3, 4, 5, 6, 7, and group 8, of course. And it goes down as well. We've got 1, 2, 3, 4, 5, 6, and 7. Now, we're going to do a couple of things here. We're going to do the electron configuration as well as answering their question, which is how many electrons do each of these elements have in its outermost shell, which is really just asking us what the valence electrons are. Is it not? So, now that I made a mess of that chart, let's go ahead and do this. Start off with magnesium. That's the first one. Atomic number 12. Let's start off with 1s2, because you're filling up 1, 2. Then you're going to, there's nothing else here, back down, 2s2. And that is here. Then we're going to our P block, 2p6, because we're filling each one of these up for a total of 6, and back to our S block, 3s2. Now, there's a couple ways of doing this. Every time they ask for the number of valence electrons or electrons in the outermost shell, as long as you're not dealing with some of the one of the transitional metals in D block, you could do it one of two ways. It's easy to either look at it and say, okay, I'm in group 2. Magnesium here is in group 2. 1, 2. This is group 1. This is group 2. Remember, this is 3, 4, and so on. Since we're in group 2, well, that tells us we have 2 valence electrons. That's the first way of doing it. The second way is by taking the highest number here, the highest group number, I guess you can say. And since we have 1 where we have 3, nothing else, for example, for 2 we have 2s2 and 2p6. So we would add those together if we were in that block or in the group 2. But we're not, we're over here. So since we only have 3, or rather 2 in the third one, we're going to go ahead and say we've got 2 electrons. Okay? It's that simple. So that's what you just found out. They asked for the number of electrons in the outermost shell of magnesium. There you have it. Really easy. Okay, let's go ahead and do the second one. It's kind of an odd one. It's called molybdenum, if I'm pronouncing it correctly, M-O. And it's number, 42. Now, I'm going to go ahead and do the same thing. This is where this one gets a little trickier. Now remember the D block? What happens with the D block? The D block gets pushed up a level, and you'll see what I mean in a minute. 1s2, 2s2, 2p6, 3s2, 3p6, 2p6. Now we're down to our fourth. So we're at 4s2. Now remember, D, what did I say? It goes up a block. So instead of it being 4d10 for all 10 electrons, it's 3d10. And we keep going back to P4. We're back to 4 now. 4p6. Drop down another one, and we're at 5. We're almost there. 5s2. And we are going to molybdenum, which is the fourth one in, and that is now 4d4. Now, they want to know how many electrons are in the outermost shell. If this were not a transitional metal, you can use one of the two methods I showed you earlier, or because this time it is a transitional metal and it's not as easy to get a grasp on the valence electrons, as we all have known through 2 semesters of chemistry, you're going to want to go ahead and grab the 2 here, because the outermost shell, you have this 5. There are no other 5s. If there were, you would add them up. This is our only 5, so there you have it, 2. We have 2 electrons in our outermost shell in molybdenum. All right, let's move on. Easy, right? Yeah, this is the first chapter. Pretty easy stuff. Okay. Let's go on to selenium. Selenium is number 34. Start by doing the same thing we did before. 1s2. 2s2. We are at, where are we? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, because we go up a level with the D block, back down a level, 4p, and what were we doing? Selenium. So we keep going, 4p6, 5s2, 4d10. There we are, going up a level again. Then we're dropping back down to 5p, and we're doing selenium, which is 1, 2, 3, 4 in. The outermost shell, well, we're in the 5th level. We add this 4, we add this 2. That gives us 6 valence electrons in our outermost shell, or because it's not a transitional metal, you can just count first group, second group, third group, fourth group, fifth group, and sixth group. And it's the 6th group, so we have 6 valence. Either or is fine. And that's it for this one. That answers that question. See you in the next one.